Standard 11 Chemistry, Unit 3, Classification of Elements and Periodicity in Properties, Part 10. Today's topic is electron gain enthalpy. We have already discussed about cation and anion. When electron is removed from the neutral gaseous atom, it is converted to positive ion, or it is said to be as cation. When electron is added to the neutral atom, it is converted to negative ion. When electron is added here, this neutral atom, and electron is added, it is converted to negative ion, or it is said to be as anion. The enthalpy is change. The enthalpy is change, and the process is defined as electron gain enthalpy. When electron is added to neutral gaseous atom, is converted to negative ion or anion. The enthalpy change in the process is defined as electron gain enthalpy, and it is denoted by delta suffix Eg. Eg means electron gain and H for enthalpy. And the process is either exothermic or endothermic. Exothermic means what? Process reaction in which heat is evolved. It is called exothermic reaction. And the reaction in which heat is absorbed, it is called endothermic reaction. Heat is evolved, or in endothermic reaction heat is absorbed. And this process, exothermic or endothermic, that depending upon the elements. Or this definition is, in another word, when isolated neutral atom gain electron, when isolated neutral atom gain electron, the amount of heat energy is gain or evolved is called electron gain enthalpy. Okay, this is the another definition of electron gain enthalpy. The exothermic and endothermic reaction, here heat energy or gain, heat energy gain or evolve. And the first electron gain enthalpy, first electron gain enthalpy is always negative, but second electron gain enthalpy and onwards, electron gain enthalpy is always become positive. So here electron gain enthalpy is quite opposite to ionization enthalpy, because in ionization enthalpy what happen, electron is removed from the gaseous atom and it is converted to positive ion, while in case of electron gain enthalpy, electron is added to the neutral gaseous atom and it is converted to negative ion. Okay, now the trends of electron gain enthalpy. In period, as we move from left to right, the value of electron gain enthalpy is increases, while in group as we go down, value of electron gain enthalpy decreases. Here in period, left to right, electron gain enthalpy becomes more negative, more negative, with increases the atomic number. For example, suppose here is second period and their elements are lithium, beryllium, boron, carbon and so on. Their atomic number is increases and their value of electron gain enthalpy becomes more negative. As increases the atomic number, their effective nuclear charge effective nuclear charge is increases. For example, here for lithium, its electronic configuration is 1s2 2s1, and it's for beryllium 1s2 2s2, for boron 1s2 2s2 and 2p1. So here is only the electron is added to second cell, so their effective nuclear charge is increases with increases the atomic number, because the atomic as atomic number is increases, z is increases, number of protons are increases. Okay, so it will be easier to add the electron to the smaller atom. And while in case of group, electron gain enthalpy, value of electron gain enthalpy becomes less negative, or it is tend to be positive value. For example, here for group 1, and their elements are lithium, sodium, potassium, etc. It's 19. Its electronic configuration is helium 2 and 2s1. For sodium, neon 3s1. For potassium, argon 4s1. So here in all three cases there are increases the cell, and because of this the size of the atom is increases. Size of atom is increases with increases the atomic number, and the distance from the nucleus to valence electron is more, or the attraction between nucleus and electron is less. So here the size of atom is increases, and the added electron would be further from the nucleus. So this is the general trend for the period and group. For period, as we move from left to right, electron gain value of electron gain enthalpy becomes more negative, while in case of group, value of electron gain enthalpy becomes less negative. Let's see about the trend in group 17. Group 17, there it is halogen group, and their value of electron gain enthalpy are more negative. Why? Because here the group 17 elements are here, for example fluorine, chlorine, bromine, iodine. Here for fluorine, its electronic configuration is 1s2 2s2 and 2p5. For chlorine, 1s2 2s2, or here we can directly write for neon, and 3s2 3p5 and so on. Okay, so when one electron is added to the fluorine, now its electronic configuration becomes 1s2 2s2 and 2p6, and while it attains this kind of electronic configuration, and this electronic configuration is as same for neon, because there are 2 plus 2 4, 4 plus 6 10 electrons, and it attains the stable electronic configuration like neon. Okay, same condition is here when chlorine gains of one electron. Now its electronic configuration becomes neon 3s2 3p6, and this the electronic configuration is for argon, because here 10 plus 2 12 and 6 electron, there are 18 electrons here, and because of this it gains stable electronic configuration. So that's why the electron gain enthalpy of the halogen group becomes negative. Here this is the reason, because they can gain electron and attain stable noble gas electronic configuration. Now for group 18, they are noble gas, and their electron gain enthalpy becomes positive. Why? For example, it's a helium. First of all, its electronic configuration is 1s2, then after neon, here neon 10, argon 18, krypton, xenon, and so on. Now its electronic configuration for neon 1s2 2s2 2p6, for argon neon 3s2 3p6. Here it's for helium, its orbital 1s orbital is completely filled by the electron. Now when one electron is entered, it is enters into the 1s2 and 2s1, means what? Here it electron is enters into the next energy level orbital. As same here, either neon gains one electron, suppose now their number of electrons are 11. This electronic configuration is completely filled, or these all orbitals are completely filled by the electrons. So now entering one electron in 3s1 orbital, and here for if it gains of one electron, total number of electrons are 9. So these single electrons will enter into the 4s orbital, and because of this its electron gain enthalpy becomes positive. Here electron has to enter the next higher principal quantum number or next cell, and leading to very unstable. Because this electron is can easily removed, and again it is converted to argon, unstable electronic configuration. And the last trend, that electron gain enthalpy of oxygen or fluorine is less negative. Oxygen, its atomic number is 8, electronic configuration 1s2, 2s2 and 2p4, while fluorine, its electronic configuration is 1s2, 2s2 and 2p5. Here 1, 2 and 3 and 4 electron is added into px, py and pz. Here for 2p, 1, 2, 3, 4 and 5th electron. Now in case of oxygen, when another electron is added to the oxygen and it will enter into the py orbital. So here one electron is already present and second electron is added. So electron repulsion becomes more, as same as here for fluorine. When one electron is added, here electron repulsion becomes more, and because of this they have less negative electron gain enthalpy, or in another word, electron is added to second cell and it suffers the significant repulsion. Electron is added to n equal to 2 or second cell and suffer significant repulsion. And the last, that factors affecting on electron gain enthalpy is same as for ionization enthalpy. Number 1, atomic size. Number 2, effective nuclear charge. Number 3, screening effect, number 4 electronic configuration, as screening effect is more, electron gain enthalpy is less, and the last one, electron gain enthalpy is inversely proportional to atomic size, directly proportional to effective nuclear charge, and effective nuclear charge is inversely proportional to screening effect. And this for electron gain enthalpy. Let's see about ionization enthalpy. Ionization enthalpy is directly proportional to effective nuclear charge, and it is inversely proportional to screening effect. And this is the comparison between electron gain enthalpy and ionization enthalpy. And as same is here, as screening effect is more, ionization enthalpy is also less. Okay friends, so this is the concept of electron gain enthalpy. Next time we will discuss electronegativity. Thank you very much.